Hello and welcome. I'm Bill Wake. We're here working on a program to assess the similarity of different musical tunes. And we've come a fair ways. We've got a Parsons Code graph, which is a graph of the shape of the melody. And we'd like to do this notion of quantizing rhythms. And let me try and explain it. So on the top there, we have something written in 4/4, which means the bottom one says quarter notes, which is the black stick and ball. And the top one says 4. So there's going to be 4 quarter notes per measure. And the measure is separated by those vertical lines. So we see 1, 2, 3, 4 quarter notes. 4 quarter notes is 4 quarter notes worth of music, and it's fine. The next measure has 2 eighth notes with little flags on them. 2 eighth notes, eighth plus eighth is a quarter. So that's the same as a quarter. The open stick, or the ball with the open ball with the stick, is a half note. That's worth 2 quarter notes. So we got 1 for the 2 eighths, 2, 3 for the half note, and another 1, 4 for the quarter note. Now, the notion with quantizing is we want to, that has a varying rhythm. Okay, so it's bum, 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 bum. Okay, we'd like to pretend there was a steady quarter note clicking along and say, what's the sound at each of those quarter notes? So the first 4 are easy because they're already quarter notes. They just become quarter notes. The second 4, the first quarter note in the lower section, in the second measure of the lower section, corresponds to the 2 eighth notes. So it's whatever the pitch the first of those eighth notes had. The second quarter note on the bottom corresponds to the half note and whatever pitch it has. And then the next one is still the half note because it's still sounding, it's twice as long. So it's that same pitch again, and then finally the last one's the fourth pitch. So we're trying to convert a varying rhythm to a steady one, and the idea is that tunes, the steady beats are usually the ones that are the same across similar versions of tunes. And so the little eighth notes might be little grace notes or something, twiddling around. We're not going to worry about them. We just want to get the basic measured rhythm. Okay. Now, we're starting that. I think what we've done so far is we've said there's the notion of a quantizer, and I guess this should be quantizer tests as well. Rename. Oh, not here. Let's see, quantizer tests, and then this is quantizer. Okay. So the quantizer we're proposing is you define some sort of rhythm, and I think we're going to have to change this a little. But what it's going to do is you give me a measure, and I'll give you back a measure that is in that rhythm. Okay, and that's going to apply that rule that I was describing with the, taking the pulse and figuring out which sound was active at that moment. Okay, where we're testing and our test failed, well, let's see here. You're not going to tell me why? That seems funny. Maybe the rename threw it off. All right, failure. Yeah, there we go. Okay, so we said we should see A and C. So this one we got a 4/4 measure, 4 quarter notes, and we're only going to take 2 of them, the first and third, A and C, and it should be equal to AC, but it only is A because we always return the first note right now. Okay, so this one, A, B, C, D, with a 4/4 rhythm, basically we're saying give us the whole note, and it's an A. Okay. Yeah, let's see. I think I feel like maybe the rhythm is what we should be saying. So I think we should say, here's the quantization rhythm. Like in this case, it's whole notes, which we could write as 1 1s. Okay, 1/1. All right, so I'm going to back off this test, and I'm going to say quantizers should take a rhythm. All right, so let's make this rhythm 1, 1. So I want the whole note, which is a 4 quarter notes. Okay. And let's go to Quantizer. I want its init to be a, let's say a pulse is a rhythm. Okay. And this, call pulse, is a rhythm. And pulse equals pulse. Okay. Now, that should work for that one. This one, we're going to need a rhythm. And let's take a half note. Okay, so half note is 2 4s. So in a 4/4 measure, there's 2 of them. Okay, and let's run this. And I think this will still pass, but I also think I'm not quite okay. Yeah, so I think it passes, but it's not quite what I want. I'm not asserting enough. Expected measure, rhythm 4/4, events A. Well, events A hides something. The problem is, well, events A creates event.notes of these, which are 1 4s. I really want a 4. I expect a 4/4 there. Okay, so let's make this more right. Okay, so I don't expect that. I expect a natural rhythm 4/4. And we already have in our rhythm comparison 4/4 is the same as 1/1. That's fine. Oh, and this has to be an event. Note. Okay. Now I just changed that. Is that right? Oh. And my test, I expect this test to fail now because the rhythm is wrong. Okay, so now measure 4/4 a 1/4 is not equal to a 4/4. Okay, so we got back a quarter. We expected a 4/4, and that's why we're disappointed. Okay. Let's. Oh gosh, I don't know where to go from here. Well, let's get the code working, and then we'll figure this out. Okay, so I'm taking. Let's let note equal measure sub 0. Make sure that's a note. It's an event. I don't think events are the right thing here. Can I say as note? Okay. Let's do that. It should be a note. I don't know, my rests and my notes, I think we got to do some work there. All right, so anyway, I have the note. Let result equal, well, I'll say new note equals note times pulse. Is that gonna be right? 1/4 times 1 is 1. No, that's not gonna be right. Let's go see note. Oops. I hit something wrong. has the note name. What I'd like is a constructor that takes a note and gives it a new rhythm. Okay, so let's add that constructor. Okay, so we need to assign note name. Accidental octave. Key. Do we store the key? What do we do with it? We don't store the key. Well, we do store the pitch. Okay, so pitch, note name, accidental octave, and then rhythm is the new rhythm. Okay, so that's the kind of thing we really need here is note with note and pulse. Okay, and then this is new note. Oh, it's got to be an event. Okay, let's try that. All right, so I'm refining the way this works. It should give me a rhythm of the pulse size. The quantizer is going to produce whole notes, and this should be equivalent to that. And actually, I think I could even say it this way, reduce it, because that matches this. Okay. And I think we'll pull this down. And let's make a variable out of this, pulse. And we'll use that up above as well. Okay, so we got a rhythm of 4/4 ABCD quarter notes and a pulse of 1/1. We quantize with the pulse. And we expect to get back a measure that's a rhythm 4/4 and a note A natural. With rhythm equal to pulse. Okay, that's good. Okay, so quantize 1 beat per bar with rhythm. Okay. Now, I mentioned yesterday, I was kind of doing I don't know, it's not really cheating because it's kind of the legit move, but it's sort of like when you do a TD and you're doing a very low gear kind of thing and you say, some complicated formula expects 42 for the answer, and you hard code the function to return 42. I'm kind of doing that here, not quite, but I'm just taking the first note and stretching it out to the pulse and returning it. Okay. I know that's not good enough. And I also know I'm not happy with the way these events. I almost wonder. We haven't dealt with rests yet. And rests are treated very different than notes, and I don't think that's really correct or helpful. Helpful is probably the better word to use. Okay. So the reason is, well, I don't like these events because I've got things wrapped. I mean, the events, like unit note length change, that's not a musical concept. These events are more the events that the parser produces. Now, some of them have some interest. Do I care about bar lines? Well, not really. I'm broken up into measures, so I don't have the bar lines. I have notes and rests still, but I think maybe a rest should be a kind of note. Like instead of the accidental, maybe the accidental is like rest, and the name doesn't matter or something like that. Yeah, I just don't know. Well, I can probably take that out of the test, that natural, right? Yeah, I think my measures should contain notes, and notes should be rests or musical notes. And do I want to get into that before I do quantization? I don't know. We pushed off so much. I hate to, but this is where we're starting to care. I mean, we had these things like, where was that as note in Quantizer, right? It's like, I'm assuming it's a note because that's what we put in measures. I think we got to do that. Oh boy. Okay, Quantizer is not in tests. I don't know why we worked it that way. Okay. And the real answer for this thing is, I don't know, I have this complicated thing in my mind, but I want to do, like, you have the pulse. Let's say the pulse was 1/4. The measure is 4/4. And we got quarter, 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 eighth, half, quarter. Okay. The example from before. Hey, Viv. Never gonna Viv. Let's see. So catch up a little bit here. We're writing a program to compare the similarity of musical tunes, and we have something. Whoops. Let's see if I can show off what it does now. Nos. All right. So we're taking in this input format for music tunes. It's called ABC. It's out there on the web. Yeah, I guess I teach TDD and refactoring and things like that. Okay, so this notation C is quote 3 means a certain octave and a duration. So it's C, B, A, G. This is really the Deck the Halls song. Okay, it's called Nos Galen. It's an old Welsh, Irish, Scotch song. I'm not sure which. But we have this input format, and if you put this in our amp, we're going to get the shape of the melody out of it. Okay, so I'm not too fancy yet, but you paste this file in. For now, we'll get an open box and eventually all the rest later. and then it produces what's called a Parsons Code. Well, the Parsons Code is really the melody's going down, 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 repeats and goes up. So I've turned it into a graph: down, 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 repeat, up, down, up, 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 down, up, up, down. And I can see these versions of this song. These two look very similar. I think of them as little mountain ranges. This one's kind of related. Oh, that's very similar, very similar, very similar. Less similar, kind of weird. Not very similar, mostly going down instead of up. Really going down instead of up. I can see that these songs are very different. This is 39 versions of Deck the Halls. Okay. And one of the problems with this analysis is the durations of the notes. So that's the numbers. So C is 3 beats, B is 1 beat, A is 2 beats, G is 2 beats. You might have a version of the song that has extra eighth notes or extra notes in it, and it'll throw off the graph, because I'll be showing you the graph for those extra eighth notes, but the other song doesn't have it, and they look more different, even though the bones of the song, the root of the song, is the same thing. So we're doing this thing I'm calling quantizing. It's not really a classic music term, but I've heard it in like drum machines and stuff. But the notion is we're going to say, I just want to count quarter note beats, and we'll take all the quarter note beats from the song. And then when we compare two songs, they have the same basic beat structure. They're going to be more similar than if you got mixed up by all the eighth notes that were or weren't there. And for us with that, this is Quantizer. We're saying there's a measure of 4/4, and we're going to quantize it to 1/1. So this is basically a whole note. Okay, so 1 beat per measure corresponds to the 4/4. And you're passing in 4 notes, but we're only going to return the first one, and it's going to be stretched out to a whole note. I guess this is a whole note as well. Okay. And the other thing I'm complaining about is right now I have this structure that there are events containing notes, and the measure is an array of events. But I think event was really something we introduced to get things parsed, and it's not really relevant now. We really care just about the notes. But there is a little twist that there's a rest event and a note event. So I'm wondering if I made if I made rests a kind of note, I think things might go better. Now, I don't think that's necessarily in the way of doing this quantizing, but we end up wrapping things in events all the time, and it's going to be a mess. It's let's see. I don't know if I can show it in the music. I'll just write it here. So if I have, I don't know if you know the tune Deck the Halls, but it's like deck the halls with boughs of holly, and it's like deck. It's got a little bit of syncopation to it. Deck the halls with boughs of holly. Okay. Yeah. Getting warmed up for the season. But this one, D3, is, so that one's going deck the halls with boughs of holly. But I could also have a version out there that goes deck the halls with boughs of holly. So deck the halls with boughs of holly versus deck the halls with boughs of holly. Well, it's really the same song. Okay. It's just a little bit of syncopation on the first one, and it makes it seem off. Okay. And by quantizing it, I'm just going to force everything to quarter notes and then more notes will likely be the same. I mean, there'll be some variation because this one quantized is going to look, the quantized version is going to look like D, D, B, A, G, G, A, G. That's quantized. And then the second one quantized is going to look like D, C, B, A, G, 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 A, G, quantized. Okay, because this one's already quarter notes. This one had that syncopation. Okay, and because we're holding that note a little bit longer. Deck the halls deck the halls. Okay, so the held out note at the quarter note level, it's actually two, let's say, two separate quarter notes. And so we'll see there's a difference in one position, okay? But if you add it up across this, it might add up to a bunch of differences with this one versus this one, whereas the quantized has fewer notes and they're more steady, so it's going to be fewer differences. Because when we got 39 versions of a tune, or I have another one that's got like 300 versions of Barbara Allen somewhere, there's a lot of stuff. In my background, that's a mountain dulcimer. Let's see if I can. If I can get my camera to bring it in. So it's a 3-stringed instrument. It's got that. Well, this one has that kind of hourglass shape, and a guitar's chromatic. It's got all the notes. Dulcimer's kind of like like you think of a piano, it just had the white keys, no black keys in there. It's more close to that. It's got a few little extra notes, but not as many as a guitar, say. So you play it. It sits on your lap and you strum across. Some people tip it up a little bit, but basically that's what it is. So yeah, that's my main instrument these days. Okay, let's see. I want to get back to the code a bit. I guess I'm struggling to know, like, should I try and straighten out this event stuff first or get my quantization done and be moving forward? I think we're gonna work on these events because we worked yesterday. We've been reworking the way the tune gets figured out in the first place. And where I'm at now is I've got metadata, which is like the title and the origin and stuff like that. And I've got the parts, which are like there's an A part and a B part. That's all the measures. The measures, let's go there. They contain events. I don't think that's right. I think they should just contain notes. And that'll simplify some of this stuff. So I'm going to jump into this refactoring. I may regret it. I don't know. Let's see. How can we start? Okay. I think what I want to do is make rests. Make rests be a type of note. And I don't know if the accidental is the way to say that. They have a rhythm. They don't really care about the note name, the octave, or the key. I don't know. Overloading this stuff is a little problematic. Like, do I care about the rest? I mean, it's a special kind of note. I think that's okay. Oh no. Refactoring gone bad. Okay. Let's do some tests on it. I think if I get note done, I can do measure, and then I can do Parsons Code, and then we can go back to Quantizer. Okay, so let's see, note tests. There we go. Okay. Okay, so I'm gonna extend this notes class to handle rests. If I could find a better name for note and rest together, I would take it, but I don't have one. Okay, so equality, rest must have this. So I'm gonna say there's a new kind of accidental. I don't know if I'm overloading that. I'll make this a rest. make this a rest. This is ignored. This is rest. Octave is irrelevant. Rhythm 2/4. Octave irrelevant. Rhythm 2/4. Okay, so the restiness and the rhythm are important. Okay, and let's put a rest. Okay, this one's 1/4. Should be different. Okay. Okay, so note 1A should equal note 1B. Problem here is I don't have, accidentals don't have a rest marker. Okay, and rest is not relevant to this. Turn 0. We don't need to put any sharps and flats. Okay, so note test. This should be acceptable now. Oh, it wants a string there. Okay. Let's make it R, X, R. Okay. This should fail. Whoops. Oh, I'm already hating this. Let's see. I think it's, okay, well, that part is good. R124 is not equal to X124. Okay, that's a good start. Okay. Let's get note equality. Oh man. Yeah, I'm not happy already. Okay. This is okay. I'm gonna revert this. Okay, let's see where we are. Oh, accidentally gotta revert. Okay, quantizer and tests. All right. I'm going to push this just to get this. Have I done anything? Yeah. Okay, so maybe event is the problem. I don't know. Note, the problem is notes really do want to compare all this stuff, pitch and note name and all that. Pitch doesn't make sense for a rest. Note name doesn't make sense. Accidental doesn't make sense. Octave doesn't make sense. The only thing that makes sense is rhythm. So I think these are not pushing them into the same box is not going to be a good deal. Okay. So where's that leave me? Well, I still think I think event is still the wrong thing. I think there should be something that knows notes and rests, and measure has that. All right. So I'm going to introduce something to split this up. Let's see. All right. Who makes the measures? Well, that's Tune Builder. Down here, it's constructing the measures. There's measure and event. Okay, so measure.append event. Okay. And measure append, measure append. Okay, so all the measure stuff is in here. This could use some work too. Okay, but I think I'm saying I want to split this out, and I want to say there's an element, and I don't know if I can justify that quite, but I don't have the right word, but I'm going to say element. It's a note or a rest. It's a symbol, sign. I don't know. Maybe I can do a little research here. Note or rest in music. Oh, Wikipedia is probably a good place to start. Rests are intervals of silence. It's a musical notation sign. Each rest corresponds to a note value for length, yes. Right. Okay, and then let's find note. Note value. Duration of a note. The note is a sound, yes. It's funny there's no word for both of them, though. I mean, note or sound, note or rest. Oh. Okay. Yeah. I don't know. I don't have a good dictionary of music or something like that. Well, let's try it again. Note or rest in music. I mean, I'm seeing symbol pop up a lot. Maybe it's a symbol. Okay, let's call it symbol for now. Can't sit all day here. All right, so this is going to be an enum, public enum symbol, and your choices are note, note, which takes a note, and rest, which takes a rhythm. I wonder if note. Oh, let's see. This goes in this package. I wonder if note should not know its rhythm and it should be out here. I don't know. Okay. At any rate, this is the way I see symbol, and I'm saying measure should take symbol. Okay, let's work out implications of that. Now, type measure does not contain protocol equatable. I don't know why I care. Oh, it is equatable. Okay. Measure symbol. Oh, so symbol needs to be equatable. Okay. Value of symbol has no member is note. Now, I think what we're saying then is a measure has symbols. We don't care about is note because they are all notes. And, oh, but this is not quite right. All right. Is that right? And then this needs to become symbol. Is that going to mess everything up? I'm kind of in this experimental stage here, so we'll see what happens. And then subscript should return symbol. And this is symbols. Symbols. Okay, I think that's okay for measures, but everybody else is going to be kind of like crazy. Okay. I don't know. Maybe this is not. It's not an enum, maybe. It was before. All right. Now we build. Anybody who used notes is going to be complaining. Okay, we know we got people doing that. Cannot return type. Okay, tune builder. Yeah, so the person building these things is very confused. All right. So character measure should be symbol. Okay. Event is right. Event.times. Okay, if it's a note or a rest, I don't see who else is messed up. Measure.append. Okay, so if we have a note, we just want to append it. Where's symbol? Let's split these up. Okay, note, we'll do one thing, rest, we'll do another. Okay, so if we get a note, let's look at event. Note takes a note. Where'd Tune Builder go? Okay. So we have the note. We want to make it note dot times that, and then this needs to become a symbol. Note dot times note length. Okay, I think that's all right. Expected parent. Sure. Okay, now this is the rhythm. And this one should become symbol.note. sorry, symbol.rest with rhythm dot times unit node length. Okay, so the two that I care about, I'm now putting in as symbols. The rest of it should be okay. All right, and then I still think the Parsons code should be complaining. Okay, quantizer, yes. Tune. Cannot convert expression. Okay, so a tune map measure to measure returns let's see, returning a note. Let's see if returning a symbol. Okay. Cannot return symbol. Okay. Try again. I don't know, the compiler is kind of waking up slow here. There should be at least one more place. Okay, and measures must contain symbols, not this. There is no need for an as note. It's just measure sub 0 is a symbol. Note is a symbol. Okay. Cannot convert symbol to expected type note. Oh boy. Okay. The deal is we've got a note. Sorry, this is a symbol. Let's clarify that. Okay. And the thing is, the symbol might not be a note. It could be a rest. All right. And so what I think we want to say is symbol dot with rhythm or something like that. And then adjust the rhythm of this thing. Build a new one with the same rhythm. Okay. Is that legit here? I think it is. Okay, let's go back to symbol. I mean, I feel like I'm kind of shoving functionality around. It's a little bit loose to call it a pure refactoring. So this is with rhythm, with rhythm of type rhythm. Okay. And now we're saying this is where that multiply times was in the other one. So well, it's not really times, but it's forcing the rhythm. Okay, so we want to switch self, and we got case.note, let note, and case.rest, let rhythm. Okay, and it returns a symbol. Okay, and this one return note with note and new rhythm. Let's call this new rhythm. in this case, dot note. In this case, we're going to return a rest with new rhythm. Okay. Case we don't really care what the old rhythm was. We're forcing it. Okay. All right. Let measure sub 0 dot with pulse. Okay. And then this becomes symbol. All right, yeah. Well, this is good. We're beyond. We're into the tests now, and not the other stuff. I still think Parsons Code ought to be caring about this, but we'll see why it doesn't. Okay, let's do a build again. All right. Okay. Measure tests. Yeah, these should all be symbols. Measure dot notes. Okay, returns us symbols. Okay, well, then this is symbol dot note. And this is a dot note. Okay. Parts parser. Notes of tune reflect its parts. Okay, so if I do tunes.notes, expected notes. Well, these are really dot notes of that. That should help that. Okay. Events. Right. I want these to be notes. Let's go here. Well, let's make a corresponding one for symbols. Okay, so if I take the note names array of this, I want them to map to symbol dot note, and this becomes symbols. Okay, this is just symbol dot note. This becomes symbols. And symbols. Symbol.note. Tune tests. Okay. Tune knows its measures, right. Yeah, so this is the moment where we're switching from notes to measures. Note events. symbols of ABCD. So here input is events, output is symbols, and we need to measure symbols. Node events, okay. Okay. Rest symbols is 4, 4 of rests. Let's see where the rest's coming in. Oh, well, we can do that here. Whoa. Is that the same thing here? Yep. I mean, I don't know if these tests are as tight as they could be, but all right, we're getting there. Rests, okay. Rest symbols are these. expected is symbol. All right, let's do a refresh. I still thought my Parsons Code should be complaining. There it is. Okay, so Parsons Code, encoder analyze notes. Where's analyze? Encoder is Parsons Code. Okay, analyze notes. Well, we think this should be symbol. I wonder if there could be a silent pitch. Maybe that would help. Symbol has no member pitch. All right, so we're trying to get the pitches out. I think we want to filter. We want to keep the ones where $0 dot. I think is note is a thing now. Is note. Okay, and our symbol does not have that yet. Okay, if I do this right, if this thing is a note, okay, I'll do it the other way. I don't think it's that much harder. Okay, symbol has his note now, but it doesn't have pitch. Okay, I think that's all right. Let's put this below. Okay, now symbol has a member pitch. Pitch 1 is lower than pitch 2. That doesn't seem right. Oh, that explains that. Okay. There we go. All right. I think we're caught up. We're run it. I mean, oh golly. Okay. Notes is ABC parser of notes. Analyze notes. ABC parser dot notes. What does this thing give us? All right, well, I'm going to give us a symbols, same kind of thing. Okay, and we'll take notes of input dot map to dot note of $0. Okay, so we'll use symbols here. See parser dot symbols. Tune builder test. Okay. Events ABC, but measures should contain. Yes. Symbols of ABCD. Okay, two failures. We will take a break and come back and address those. My assumption is it's not a big deal type thing. Oh, they both mention REST, so we've probably done something wrong with REST handling in our test. All right, so see in about 3 minutes, and we'll pick up from there. But we're close. Welcome back. All right, let's see what's going on with these two tests. Okay, so notes ignores rests. Oh, maybe we don't make that true right now. In a measure, I think I think that's not really true. Okay, it's a change in behavior for sure. Let's see what this one is. Rests are allowed. Z rhythm. Okay, what does this mean? Where's the actual complaint? Oh, notes. Yeah. Okay, so maybe notes should just return the notes. Okay, let's put that back in. Measure.notes. Measure symbols, return symbols. I don't know. I think let's go to tune.notes. That's where it really hits the road. Tune. So we have this, and it gets the notes from the measure. All right. What's this one saying? Check rest parsing. That's kind of saying well, that's kind of not what I expect. We may be hitting a place. One of the things we did was with Parsons Code, you only look at the notes, you don't look at the rests. And I think what this test is saying is if I have rests, they don't show up in the tune. And I think that's kind of wrong. I think we should return everything. So here's expected notes, and that's really expected tune builder.make. Well, it's really expected events. Okay. All right. I think we're changing some features here that I think we should change. Notes. Let's say returns notes and rests. Maybe he should become symbols. Okay. Measure is rhythm symbols. Well, this should definitely have that. I think you should just get back symbols. Okay, that test succeeded, but this one's still funny. All right. I think notes is the wrong name even. I think it should just be symbols if that's what we're calling it. And then this, check tune parsing. Well, this is really the Z or X thing, right? I think we should filter on that. A, B, C, D. Rest can be followed by slash. Okay, this is a different thing. Let's make a new function for it. Test both notes and rests are returned. Okay, and for now, I'm going to make it just A, Z, B, X. And it should be A. Well, the equivalent of this one would be this. All right, and this test should fail, and if it does, I'll take out this piece. Yeah, that test fails, so this piece should be close enough. Okay, now this check tune parsing. Expected note names, that's not enough. Note lines, note names, string what? Note lines. Let's add a version. Check tune parsing. Okay, and it's I guess I want that one. All right, let's see what I'm doing here. Okay, check tune parsing with expected note names. Well, I want to make expected note names turn into expected events. Okay, and then I want to call check tune parsing header lines, note lines, expected events, and what? Okay, and then this is expected events. It's an array of event. That's passed in. Event.node. And then oh no, that's not going to work. That's the duplicate. Should be back to that failing test. Okay. So I need my own version of check tune parsing is what it comes down to. And what I'm passing in is symbols. Oh, no, that's not so far off, is it? All right, let's pass. That's really just this with header line empty. Let's switch to that. This should still fail. Okay. Checked in parsing expected note names. Oh, okay. I think I can say all right, what I'm going to do is check if name equals X or name is Z. I'm going to return event.rest of a quarter node. Else, I'm going to return that. Okay. So I'm going to put the events in, not filter them out, which seems okay. This should fail. Right. Okay. So I get A rest, B rest, which is what I should get. Current code is returning AX, or the current test. Okay. So it's now it's the test that's wrong. This, no, wait a minute. That's the input. This should be a ZBX. Well, that failed. Is it a question of quarter notes? A rest 1 1. Oh. B note 1 1. A 1 1 rest 1 1. B 1 1 1 1. Rest a quarter. Oh, they should be 1 1s. Oh my gosh. The reason is when you're talking about events always have 1 1 for the rhythm. Okay, so I think we're green now. God. Okay. Make measures hold symbol instead of event. Well, okay. And I don't know, some of this stuff is a little awkward, but let's move on. Close the tabs. Okay, so what are we doing here? Handle other quantizations. Well, we haven't even done that. What we've done is make measure hold symbol instead of event. Okay. And that's actually a good thing. I mean, I think it will simplify things for us. November 16th. Quantizing rhythms. Okay, make measure hold symbol. And we also switched to take rhythms rather than counts. Okay. Quantizer. And quantizer test quantizer. Okay. Oh gosh. 1 beat per bar. Let's call it quantize to whole note. Okay. And this one is quantize to half note. All right. So measure 4/4, symbols ABCD, rhythm 1/2. The measure we expect is a 4/4 with symbols AC. These need to be half notes. Did our test on the first one? Rhythm. Expected measure. Yeah, we were explicit here. Let's be explicit down here too. There should be 2 notes, A and C. And the rhythm is the pulse. And the pulse is half note. Okay, this should fail. Not quite what I expected. Invalid. Oh, that one is. Okay. Now it should compile and fail. Okay, we just got A, not AC. Notice it did have the pulse right, but it didn't fetch enough notes. Okay. This is where I have to blend these lists and make them come out right. So what I think should happen with the pulse, right, that we should take the pulse times 0, no, pulse times 1, pulse times 2, 3, 4, etc., until we run out of beats in our measure. Okay, so let's start there. Symbol. Let's take measure. Let time signature equals measure.rhythm. Okay, why is that a function? Measure's not really pulling its weight as a enum, is it? Okay, we'll come back to that. Let's make a note. should measure become a struct? I would think it's the real question. Okay. So we've got the time signature. What I'm thinking we want is a list that's like pulse, 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 added up. Okay, so I want to say the pulses well, how do I write an infinite loop here? Infinite sequence in Swift. Yeah, lazy infinite sequence, okay. Result 1 dot slash dot lazy. Okay, so let's take 1 dot lazy, because we want to map just one at a time. All right, and we want to map that to pulse times pulses. Nope, times $0. Okay. And can I provide a type int to expected argument type unbounded range? Okay, well, dot, I don't think we want first. I think we want like while, keep. Dot. Prefix length through. Prefix while. $0 is less than time signature. We don't really have everything yet. Cannot convert int into expected argument type unbounded range. Let's see what we got here. It may be that because I don't have the additions and all that stuff. Okay, that one's okay. Binary and binary cannot be applied to rhythm. Remember lazy. Let's see what goes on here. Okay, that's okay. But I think we don't have a times rhythm $0.01. Okay, how's that looking? Okay, so if okay, so we're gonna take all our numbers, we're gonna map them to them times the rhythm of that one. So 1 times a quarter note, let's say. 2 1 times a quarter note is 2 quarters. 3 times a quarter, 4 times a quarter. Okay, and then I think we're going to take the prefix, and then we don't have a comparison. And this should probably be less or equal. Okay, so $0 is the rhythm of that. Okay, and less or equal is not in rhythm. Okay, so let's write that guy. Okay, I gotta think about my fractions a little. Let's see. If you have A divided by B versus C divided by D, I think you multiply, right? Multiply diagonals is AD versus BC. Okay, so if I have 3 halves versus 2/3. All right, is 3 halves bigger than 2/3? Yes, it is. So 3 less or equal should be false. Okay, so I take 3 times 3 is 9 over versus 2 times 2. $80 less than or equal. Okay, so let's compare 2 to 4 4. Okay, 2 times 4 is 8. 2 times 4 is 8. Are they less than or equal? Yes. Okay. 3 times 3 versus 2 times 2. 9 less than or equal to 4. No, it returns false. And then 2/3 versus 3 halves. We get 4 less than or equal to 9. It's true, and it should be. Okay. So this is self.numerator times other denominator is less than or equal to self.denominator times other.numerator. Okay, let's see. So this should be defined now. Okay, and let's just take a look here what we got. Pulses. Okay. Let's run that second test. And I'm expecting to see 1/2, 2 halves, or the equivalent. Well, that's certainly not what I expected. Where did my pulses come? Quantizer. Well, I don't need a result. Okay, let's run that test again. Step over. Oh, interesting. What? Nothing's computed if we turn it into an array. Okay, fine. I thought printing it would be enough to trigger it. Step over, 1/2, 2/2. Okay, well that's what I'm expecting. Okay, so that tells me that's the quantized pulses. All right, if I had 1/4, 4/4, or 1/8 to 6/8, that would be good. Okay. Now, I need to go through let me do this. Pulses dot for each print $0. I haven't used lazy stuff here much. Make sure it does what I'm thinking it does. Okay. It printed those things. Okay. So what I think needs to happen is we need to go through the pulse. Okay. So we're going to run through the pulses. And we need to worry about, let's make a rhythm. This is captured so far. I don't know. It's the I want the ongoing rhythm of my measure. Let's talk current. Okay, and this is rhythm 0, 1. Okay, so we have accumulated nothing so far. Now we're going to we're taking a pulse. Let's call it target for a moment at least. Okay. Well, I can do that better. Okay, let's call that the target. And we're going to say while current is less than the target. I don't know if I'm going crazy on this. All right, I got to get some stuff in there. Okay, so I need to keep accumulating until the current is at least as big as the target. Okay, so while the target is less than okay. Well, while current is less than target. Okay, we'll backfill less than in a moment here, but I've got to accumulate some stuff. So I'm going to say current equals current dot plus I guess I need a counter too. Index equals 0. Counter is 0. Okay, matter plus counter. Okay, so I'm going to move forward in my measure. And this kind of assumes measures are good. Okay, so while the current is less than the target, in other words, we haven't got enough rhythm accumulated, and the index is less than measure.count, in other words, it's safe to access it. I'm gonna pull in pieces on the counter, and when I exit this loop, boy, I'm working too hard. Okay. I like having these pulses. I mean, that's a good thing. Maybe I can simplify this. I don't know. I want another variable. Bar last note, last symbol. And I'll say it just starts as symbol.rest. So I don't know, these 0 places. Okay, so what do I need to do? Well, if the measure is less than the target, then I think current is really beats so far. Okay, so it's kind of starting out 0. Last symbol is the last thing we read, and so last symbol equals measure sub counter. Okay, so we're going to capture the current symbol, and sorry, this is counter. Capture the current symbol, add its beats to beats so far. And then add one to the counter. Okay, so we're gonna keep going on the symbols, but we haven't captured it yet. Okay, and then result is array of symbol starts out empty. Ugh. Okay, so when we get here, I don't know. It's a long time to be read. Okay. When we get here, we now have a symbol. The last symbol is the one we want to capture. Okay, so let's do result.append last symbol. Okay, and we'll accumulate results until we've finished all that. Okay, so now measure.rhythm and symbol measure 0 with pulse. Okay, that is last symbol with pulse. Okay, so we're going to take each symbol, match it to the pulse that we started with. Okay, and then down here at the end, we want to put result. We can turn that off. Okay, right. Okay, so, well, that feels like what I want. Do I have a plus on rhythm? No, why aren't you complaining? Okay, I need a beat so far is a rhythm, right? So he needs less than and he needs plus. Why is measure.count? Measure dot notes dot count. Okay. All right, we need less than and we need plus on rhythm. All right. Less than other rhythm. Bool. Okay. Well, it's really this. Okay, and then plus, that is trickier. I don't know. Plus another rhythm Ghostwave rhythm. Okay. And I haven't been reducing fractions, and maybe I should. All right. We need to get a common denominator. I don't know if there's a least common multiple. Or GCD. I don't think we have either one, right? There is no GCD. Okay. Oh, do rational numbers do it? Vector of numbers. I don't know if I want to do that. See, I don't need the floating point stuff. Okay, GCD AV equals AV. Well, B not equals 0, AV equals B. Yeah. Okay, so the greatest common divisor. I think I want to set this aside and do this as a separate test. Just, it's getting too deep. Okay, so let's find rhythm tests. Okay. Test rhythm plus. Rhythm 2-4 plus rhythm 3-6. Well, 2-4 plus, let's see, 6/8. Should be equal to rhythm 1/2 plus 3/4 is 1 1/4. So that should be 3, 5/4. Two 4 is 1/2. 6/8 is 3/4. 1/2 plus 3/4 is 1 1/4. 5 1/4 should be true. Okay. That's a much easier thing to check. Okay. Right. Let's just return self. Should fail. Should get, whoops. Bool. To expected argument type int. And counter less than measured as. Beat so far. Should be a var. Okay. What? Symbol to rhythm. Measure.counter rhythm. Okay, let's hold off on that. We're working on this other test. Oh. I guess it's good I'm running more vars or less vars. Okay, rhythm test. Try you again. Should fail. Right, 2-4 is not equal to 5-4. Okay, so we just returned the first one. All right. The easy way to add these well, okay. We take some of this into account when we do it. So if you have A over B plus C over D, you can take dA plus, sorry, let's write this out. A over B plus C over D equals D times A plus B times C all over BD. Now, what that's not doing is it's not reducing any fractions, and so we're going to get some big numbers pretty quick. Okay, but I think once we get this, we can we get it working, and then we can simplify it, because we don't care. We're always going to treat 2/4 and 1/2 and 6/12 and whatever else the same as being a half. They're equatable. We don't require that the numerators match or anything like that. Okay, so this is rhythm of other dot denominator time. Well, let's do it self dot numerator times other dot denominator plus other dot numerator times self dot denominator, all that over self dot denominator times other dot denominator. Make sure parens match the way you expect this. If we're going to put this on 2 lines, let's do it like that. Okay. And I think that should pass the test. Okay. But the reality is this thing is now 16 30 seconds plus 32 48 30 seconds. No, is that right? Well, it should be in 30 seconds, right? So it should be 40 30 seconds. 2 times 8 is 16. 4 times 6 is 24, is 40 over 32, the product. Okay. Yeah. So it's 40 30 seconds with 1 multiply, and you could easily divide by 8. Okay. So the change would be, well, let's check less than and less or equal. And I think we can make less or equal should be, it should be able to be less than other or self dot equals other. That's the equatable static function does. I don't know. Maybe I should be putting in static functions for those too. Let's write a test and do it. Okay. Rhythm equality. Okay, let rhythm 1 equals rhythm. I'm going to let myself use 3 in the denominator. I don't think we care, and maybe when we get to triplets and thirds, we'll need to, so 4 halves. Okay, so what we want to say is that rhythm, well, maybe I should get something closer. How about 3/4? 2/3 is less than 3/4. Assert true rhythm 1 is less than rhythm 2, and assert false rhythm 2 less than rhythm 1. Rhythm less than. Okay. Cannot apply binary operator. All right, let's add an extension. Okay, so well, we'll do this. Public static function less LHS self, RHS self, to bool. Okay, and this is self dot. Sorry, LHS, RHS, LHS, RHS. Oh, let's say false. We'll just make it fail for a moment here. Less cannot be a. Yep. Okay. That reads nicely, doesn't it? Okay. Good. Our quantizer test should fail, but our rhythm test should pass. Oh no, it shouldn't. We return false still. Okay, so we're returning hard-coded false. Let's do the real thing. Assert true rhythm 1 less than or equal to rhythm 2. Assert false that it's less than. Oh, rhythm 1A less than or equal to rhythm 1B. Rhythm 1A assert true. Rhythm 1A is less than or equal to rhythm 2. And assert false. Rhythm 2 less than or equal to rhythm 1A. Okay. I need another operator. Okay, that should be failing some of these now. Why are you failing? There we go. assert true failed. So it failed rhythm 1 less than or equal to itself. It succeeded with the two that are actually less than. Okay. Less than or equal, we said should be this. You know it's working right when you get stuff like that that just seems so like an algebraic or axiom setup or something. Okay, and then I think I deleted the method for less than or equal that somebody needs over here. Yeah. Oh. Less than. No, somebody should be complaining. Rhythm, there it is. Less or equal. Time signature. Okay. Now, these tests should pass. Okay. Let's take this test out for a moment. Ignore that. Does this test pass? Let's ignore that for a moment too. Okay. And test rhythm, lesson rhythm, and rhythm less than or equal to rhythm. Okay. No, push and commit. All right, now quantize to whole note. We want this to pass. It doesn't. What's the matter? Well, let's just run them all. Okay, this fails. What's the matter? 4, 4 with D, 1, 1 is not equal to A. That sounds like we picked up the D. We want the first one, not the last one. Okay, so I think we have to beat so far less than target. Okay, and the first one, target, it's a measures 4, 4. The pulse is 1, 1. So let's see if we look at pulses. Let's just stop here. Okay, and run the test. Okay, so print target. Well, I think it's saying it's 1, 1. Okay, so, maybe our count needs to start at 0 here. because we want to pick up that first note, not the last note. Okay, let's try this again. That fails. Beat so far is never mutated. Oh, well, if I'm not going to do the stuff, you can't expect it to work. Beat so far equals beat so far plus measure counter dot measure counter, that's a symbol. Okay. And I want to know the rhythm. Okay, so let's say public var rhythm is well, again, we have to do this sort of switch-based programming, which gets a little old. Type annotation missing in pattern. Okay. Rhythm. Okay, if it's a note, return note.rhythm. And if it's a case of rest with let rhythm, we'll return rhythm. Okay, so can I ask the rhythm of this? Quantizer measure dot rhythm. Okay. Good. Take that out. Run this test again. Okay, that's getting old. Measure symbol D. Okay, did I change that to a 0? I think I need to do that. Sorry, get that thing balanced out. Okay, now what? Measure 4 rest 1 is not equal to measure 1 A. Okay, I think we're ready to critique this. Pulse comes in with 0. Well, beat so far less than target. Beat so far is 0. Pulse is 0. Sorry, target is 0. Beat so far less than target. Is that true? Well, no. Beat so far less than target. Well, it's equal to target. If it's equal, I want to pick up that first one. Okay, let's do that. So beat so far equals target. 0 equals 0. Then we're going to take the last symbol as measure to counter, the first node. Beat so far is plus measure counter dot rhythm, which is a quarter note, I think. And we're adding a quarter. So beat so far is a quarter. Incrementing counter. Okay, we append the last symbol, which was A, the first note, and assign it the pulse, which is whole note in the first test. Okay, we come back around. There is no target. Okay, let's try this. Okay, now let's take this one. Okay, well, let's capture this. Okay, so we work for 1 note per measure. Okay, now we'll take this one out. Maybe this it feels like we've been here all day in some way. Okay. This one we have 4/4. Okay, well that's a good sign. 4/4, the pulse is 1, 2, quantized by the pulse. And we expect to get half note A, half note C. Okay. That's good. Let's I want to do a weird rhythm, like a 5. Would 5, 4? Okay, I think we're gonna have to find. Well, it would be nice to. Let's see if we can. What kind of parameter is this? Okay, so we'll say check quantization. I don't think we need to say throws. We don't have any tries in there. Okay, so we're gonna need the quarter notes. Quarter note names is a string. Okay, symbols of quarter note names. Names. Okay, so that's one thing we need. We need the rhythm. Okay, so the measure rhythm is a rhythm. And I think it almost is worth naming these. What's quarter note names? This is measure rhythm. We need to quantize to a rhythm. Okay. And then the expected. Well, I think the measure rhythm is the same. And then we have note names. Of string. Okay, and this is let's say let expected notes equal, and we're going to take expected note names, and we're going to map them to the rhythm of the pulse. Expected note names. Okay. This is symbol. Did I get one too many? 1, 2. Yes, I did. Okay. And, oops, can I convert value of string to symbol? Oh, expected notes. Let's call it expected symbols. Okay. And I would expect that to be the same as check quantization. Measure rhythm is 4/4. Quarter note names is ABCD. Quantize to 1, 1. Expected note name is just A. Okay. Oops. Cannot convert value. All right. This should pass. Okay. And now this one. It's a 4/4 rhythm. Quantize to 1, 2. Expected note names is AC. Whoops. Okay, test shall pass. All right. And, well, let's see. To be okay, and then tomorrow, well, we handled, excuse me, handled quantization by whole or half note. Okay. We still need to handle quantization where notes go past the pulse, e.g. half note at quarter note pulse, or maybe a dotted note. And I think we need to handle quantization with rests. Okay. All right. I think just the to-do, that's fine. All right. So we will pick up there next time, which is tomorrow. It's at Eastern Time, 1 to 3:30 p.m. or UTC 6 to 8:30 p.m. And I'm pretty confident we'll get the quantization worked out next time. And then we'll probably look at hooking it into the reporting stuff and go from there. Um, this is uh, this is a pretty long project. I don't know. There's a lot more we can do. We'll do some assessment at that point and figure out what our next focus is. All right. Thanks for joining. Hope I catch you again sometime. Take care. Bye bye.